So there was a question in the chat from Jim's presentation. How much does static play into the dust flow mechanics on steep slopes here? Jim, I don't know if you want to hop on and answer that, and then we can continue with other questions.
How much does the what?
Static play into dust flow mechanics on the steep slope.
Yeah, that's a really good question. I think downslope movement of regolith is an unknown. Okay, I'm sure Jack can tune in with some personal experience there, and we have that from also Dave Scott as well. But I think the work we've been doing kind of theoretically and looking at diffusion and other things, I think that we just don't know the answer, and that's a factor we'll consider. Hadn't really thought about that, but we'll put that into the hopper for trying to figure out what the role in diffusion, the role in impact cratering. While I have the floor here, one quick point here. Some years ago, I gave a talk on talking about crewed missions to the moon and Mars, and Carl Sagan pulled me aside and he said, "Jim, don't use the word crewed. Do you know how awful that sounds? Use human and robotic." I'm just saying, okay? So,
sorry about that if I was an offender.
No, we've all done it. So, Jack, you want to make a comment on that?
I would only say, in my observations, the photographs you showed of downslope movement into craters certainly duplicate what I saw. And I never thought of it as anything more than probably the cumulative effect over millions of years of small macro and micro meteorite hits, which will bias movement in the gravity field downward. Now, over on the South Massif, there may well be the added, and this could be almost anywhere, seismic movement, because I think we're continually collecting evidence now that the Lee-Lincoln fault, thrust fault, had multiple episodes of seismic activity along it. Now we've identified 3 avalanches that have been triggered off the South Massif. Originally, we only thought there was one, and that led to the Tycho-Ray hypothesis, which still is feasible. But when you have a fault there that's apparently active over time, the total throw is about 500 meters. It makes you think that maybe it's the primary cause of this gradual mass wasting as well as major mass wasting events.
One thing is that one of the critical issues in the elephant hide terrain and the downslope movement is that micrometeorite bombardment and diffusional deformation, diffusional modification doesn't seem to explain it alone. Clearly it has to be a factor, but maybe even at a small scale, the seismic effective impacts is really underappreciated too.
Jim, if you have the time, take another look at the craters on the South Massif and see how they compare, because we do have a pretty good age now on the youngest light mantle, about 54 million years.
Yep.
And that's what's missing, of course, in the South Pole Lacan is that precise an age determination. So over 54 million years, you will see craters that have only formed in regolith that age or younger.
Excellent. I'll do that. Thanks, Jack.
Yeah, the old light mantle there is probably around 83 million years, but most of the surface was pretty well exposed. The slope of the South Massif was pretty well exposed then about 54 million years ago.
Great. Thank you.
Got two separate ways of figuring that date, and it comes out about the same.
Tom, is your question related to that? Because we do have a couple in the chat that I want to make sure that we can distribute.
I just wanted to reinforce the point Jim has been making and the sort of consideration of working on slopes, especially those that have been clearly showing downslope movement. And as I showed in the models I did yesterday, there are a number of places, including at Malapert in and around, where I'm seeing evidence of slope instability in the model. And it's not to pick on Malapert. There are other areas around the South Pole that have these same sort of slope instabilities. So, I mean, this idea that I think you want to be very careful because I think landslides are a very real possibility in these areas and could be triggered by our or astronaut activity, in fact, if we're not careful. And again, Jack has great experience about what slope can do to you when he tried to drive up the Lee Lincoln Scarp.
Yeah, I tell you, handling landslides probably will result from relatively small stimuli if your slope is greater than about 26 degrees. That's what the South Massif, the comparison of the South Massif and the North Massif tell us. No evidence of landslides on the North Massif. Obviously, maybe as many as 5 mass wasting events off the South Massif. So that's one consideration. The other is that when you drive a rover or an LTV, you're going to go cross slope rather than upslope. But standing and working on a 20-degree slope, as I indicated in the chat, was very difficult at Station 6. I was working on the face of a boulder. The slope was about 26 degrees, and I literally had to tread dust in order to stay next to the boulder. So, yeah, the slopes will make a big difference. And a lot of that's what we can do is going to depend on the XEMU. And again, I have a hard time gathering data on that. Dean Epler's up. Dean may have more information than I do about the XEMU.
Yeah, so I was just going to say I had just recently seen some pictures of the LRV tracks between Station 6 and 6A on 15, and you can see these little sloughs off both the footprints and the rover tracks. They're not long, they're not, sort of long run out things, but it's clear that the as stimulated, the material slips downhill. Relative to working in the XEMU, I tested an early variant of that with a 2-bearing hip, and we're going to have the same problems. You may be able to lift your feet up a little higher, but you're still going to tread. So
I might say that running downhill on a 20-degree slope is great.
Yeah, we remember that, Jack. We remember that. I think you were singing a song at the same time, right?
Yeah.
Yep.
I've been trying to convince people of that, but nobody believes me.
All right, well, Paul, we've got one for you in the chat. What type of data would allow rapid DEM generation and micro cold trap thermal models? LiDAR, stereo images, or something else? In the context of Artemis 3, would the data be acquired by the astronauts and processed during or between EVAs? And that's in the chat. I know it's a long question.
No, I think I got it. Thanks. So actually, the Viper team has been doing a lot of work on this, given that they'll be facing similar challenges. So the idea is that you can actually use images from the surface in the same way that we use stereo imagery from orbit to do stereo photoclinometry and that sort of thing. And there are very highly validated models for doing this with multiple images acquired of the same scene at different angles from the surface. You can actually get an app for your iPhone that does this. So the accuracy is good enough for the types of DEMs that we would want to generate to make 3D thermal models in real time. As I said, the kind of processing time to produce one of those over a given region might be roughly hours. So we could do it, during an EVA potentially, if that matches. But in between EVAs, then you could acquire images from the lander or of a region that would be revisited later, and maybe have a little bit more time to produce those products. If you don't have the ability to produce any DEM, then you can use the knowledge of the local slopes and the images of shadows on those slopes and their geometry to estimate the likelihood that a given shadow is permanent and that shadow is a cold trap.
Great, thanks, Paul. And this that question and your answer actually lead into a question in the chat for Alex. The PSR1 from your slides has a significant sun-exposed crater wall that may lead to heating the shadowed portion of the crater at the diviner scale. There are numerous meter scale blocks on the crater floor. Would there be potential for micro cold traps in the north facing side of the large blocks?
Yeah, it's a good question. I was actually puzzled by the diviner data on that PSR. So thanks for the additional information. If anyone who works on diviner wants to chime in, that would be great. But regarding the boulders on the floor, I mean, it's certainly a possibility, and maybe Paul can provide some more detailed information on that. Just thinking about the geometry of the crater and what I've seen in LROC imagery, I think the problem would be shielding those areas. So to the north of the boulders, when the sun is at the east and the west, it seems like that's when the amount of shadowed area inside that crater is minimized. So I'd say it's worth looking into, and I would be glad to dig back into LROC imagery and get back to you on that. But my guess is that if there are any smaller PSRs due to those boulders, I would guess that they are relatively small in scale. Does that kind of answer your question?
I think it does. I think so. Yeah, from the
Thanks.
chat. Jim, there are a couple of other questions for you from the chat. There's a question: what is the runout distance of the downslope transported material, either on shoulders of mountain craters or base of Malapert massif? Is the reduction in craters or elephant height texture the diagnostic characteristics of extent of transported material?
Yeah, I think using the term runout distance is probably not appropriate. That might be something for the Apollo 17 South Massif landslide, so to speak. And but these things, you know, we don't see runout distances per se. We just see this elephant hide texture, and clearly it's like we saw in those cases. It's modified slowly and very effectively on a kind of like short wavelength basis, the terrain. So, you know, really, I think a much more quantitative study needs to be done. If you check out, we've started to look at that with the Kreslowski, Bondarenko, and Head paper. It's actually an abstract in 2021 LPSC, but the key here is that there is not a constant occurrence of the elephant hide terrain as a function of age, for example. You might have a similar slopes, younger, you know, like a Copernican age crater with a slope of 25 degrees, might not have it. And, you know, so there's an age issue here too, but we still don't fully understand what that is. And I'd also underline, I mean, going back to what was pointed out by Tom Waters yesterday, if you take a look at his incredible movies of the seismic disturbances propagation, exactly the same thing is going on for impact craters, okay? We just don't fully appreciate that. So each impact crater creates a seismic event. And so, you know, that's another aspect for asymmetry and heterogeneity in any kind of this downslope movement, because it's not linear, okay? The decay away from the impact is not linear. So that's another complication. So I would just really encourage everybody to join us in trying to analyze the elephant hide terrain. And I hope on Artemis 3, we can actually make some progress with soil mechanics experiments and observation. Certainly we'll be getting a lot of observations as the astronauts, using Jack's term, tread dust or whatever it is when they're on these steeper slopes.
Great. Well, thank you. Go ahead, Jack.
One quick thing on electrostatic. I am not aware of any evidence, operational evidence on any Apollo missions of definitive evidence of electrostatic transport. And the rock surfaces are clean, every one that I saw almost, except, unless they'd had some crater ejecta on them for some reason. I'd be careful about letting that drive any of your decision making. There, yeah, dust adheres, very fine dust adheres to the helmet visor. As a matter of fact, I think we had a little bit of dust on the television lens. However, there's not any definitive evidence that it ever bothered the Hasselblad camera lenses. But I think the one thing to keep remembering is that all the rock surfaces that we've observed pretty much are clean. And so transport of dust seems to be unlikely.
There was a dust detector on Apollo 17, and the reports, from orbit of essentially Terminator kind of obscuration, which suggested that there might be some Terminator, when a Terminator passes, that might produce some electrostatic mobilization. But I don't know where that stands right now.
Well, the dust detector has a variety of interpretations.
Yeah.
And one of them is that they sense dust, but there were some electronic signals too, apparently noise, that has caused some debate about that. To my knowledge, the Latty experiment, although largely designed to see dust, saw none.
Mm-hmm. Good point.
But I'll tell you, if you look at the horizon from orbit, that so-called horizon glow, I think is a long path length in the atmosphere that could be a combination of a little bit of dust, although I don't think so, but also the transient atmosphere of the moon, giving you a little bit of a glow over a long path length. You got to remember that. And that was my impression when I was in orbit around the moon looking at sunrise.
Mm-hmm. Interesting.
Well, thank you everybody for your presentations as well as this lively discussion. That rounds out the Malapert candidate landing site session, and we will transition over to the workshop summary discussion.
Thank you guys so much. This is we were really nervous to do this, but I was like, they're all there in one place, and I don't like to say things a bunch of times. Can we just do it now? And I was like, yeah.
Okay, so we're going to move on to the workshop discussion and the summarization of what just happened. So first and foremost, I want to thank everyone for all of your hard work. I know that the timing of this following LPSC was a challenge for many, so we are aware of how challenging it was, and I really want to thank you all for all of your hard work as we all start to go down this path together.
I'll hang in the background and just listen unless you have a question. Okay, I'll just you.
And so one of the things that I also wanted to make clear is that everything you did here, everything you said, all of your presentations are important and they are valuable to the agency and to all of us who are working on these issues. And we look forward to starting, this is really just the start of a conversation. So we're going to be digesting all of this great data as we inform our site selection process. And we do look forward to another workshop later this year, early next year, as we start to refine our figures of merit in consultation or in association with the community and our various architectural elements. So that said, I wanted to sort of discuss some of the observations that I had as we sort of were going through the workshop. So obviously, illumination is important. So I think it was Jim Rice who was like, "Boy, I hope NASA's got people working on illumination." And I rest assured everyone, yes, we do have people working on illumination and tracking the relationship between illumination at the moon for a given set of launch windows. And so, yeah, we are tracking that pretty closely. It is a relatively complicated set of issues. I think one of the interesting things for me, especially watching the talks yesterday, was that we're depending a lot on the data from our flagship mission at the moon, the Lunar Reconnaissance Orbiter. So one question that came to mind, which was actually put to me by the LRO project scientist, Dr. Petro, was what sort of additional observations may be needed from LRO to either support Artemis 3 activities or support future LDEP missions to the surface of the moon. The third thing I sort of observed, and this is not necessarily a new observation, and it comes through pretty clearly in the science definition team report for Artemis 3, is the relative emphasis of volatiles versus chronology. So for I thought the new geological map that Professor Head discussed yesterday was amazing. And I think more products of that will be important, but we are depending a lot on these sort of basin injecting models and model-based parameters for understanding what the contributions of various basins surrounding some of these landing sites in the South Polar region. So a good sort of question, good thing to think about is what additional work may be needed to refine some of these models. Another thing which I sort of, I think was brought up a couple of times is don't forget the influence of tectonics. Could be very interesting investigations that could involve tectonics, and that was, I think, highlighted pretty clearly by Dr. Waters yesterday. And the other thing that sort of was, I think, hit pretty hard this morning was sort of some interesting questions of, is there value to repeat visits to similar set of locations, or do we want to try to prioritize diversity? That was, I think, eloquently asked by Dr. Cohen yesterday. So those are some sort of discussion points, but I did want to take this moment to try to open the floor up for some discussion for some of our distinguished members of the community. I see Professor Head is raising his hand and eager to speak.
Oh, well, I just wanted to know, Sam, really, I just want to congratulate the committee for, I understand you had a few problems getting things set up, but it was really great. It was really great to sit through everything, and you're on the right track. I just had one question. During Apollo, the site selection process involved a lot of people from the outside community. It was a totally transparent process. I wonder if you could summarize the Artemis site selection process quickly, just in summary, so that everybody knows how that works.
Yeah, so unfortunately, Tamara George is not here today, but there is a CASA, the Cross Artemis Site Selection Authority, and that is actually that's the group that has the job of making recommendations up to the decisional authority, which will be ultimately the ESM DMD Associate Administrator in consultation with the NASA Administrator. So we do actually have a pretty well-potted process. Now, when you say it was transparent for Apollo, I am aware of the influence of the the so-called rump group, which made a number of decisions. So it was a process, and it did involve the Woods Hole meeting, and it went through the rump group, and decisions were ultimately made by Rocco Petrone, or the Apollo Systems Program Office head. So it's sort of we have a sort of similar process here. We started with a set of public documents that were vetted through League and other, and resting on the Constellation body of literature. So I wouldn't necessarily say the process for Apollo was a sort of transparent, what we'd say is the modern sense of the word.
Well, I would disagree with that, because the Group for Lunar Exploration Planning and, a whole series of public meetings were held where all this was discussed, including the Apollo Site Selection Board meetings, which Rocco Petrone chaired. So yeah, anyway, I'm sure it'll be fine, but just please keep in mind that there's a lot of outside input that I think was completely involved in Apollo, and that's really, you're trying to convince the community as well as provide NASA with the best possible advice, which can be helped by input from the outside. Anyway, that's fine.
And that's exactly why we're having this meeting, Jim.
Sounds great.
Hi, Sam.
Any other comments? Okay, Pascal?
Yeah, so I just have a couple of quick points. First of all, thank you everybody for organizing this workshop. I heard yesterday from Tamara, maybe I misunderstood, that the down select process was going to involve a down select first at the regions level among the 13 candidate landing regions, and then one would then focus on down selecting to specific sites within the finalist regions. And maybe she was just summarizing the process without really emphasizing the iteration that might be needed. But I wanted to just point out that if all we did was down select from regions, and then only at that point starting to look at sites in detail, we might be overlooking a region that overall might not be very, very attractive, but might have a single site that actually could be, really compelling. So because we're looking in the case of Artemis 3 specifically at a short duration, short range, 2 kilometer on foot only mission, it's really down to what specific site you're going to pick to get the maximum science return from it. And so it could be in a region that doesn't necessarily stand out in a huge way, but on the other hand, down to the site level, it could be an extraordinary site. So I'm just hoping that that down select process is going to involve some iteration still between regions, sites within them, and then of course focusing a lot more on specific sites once we have a sense of the best sites within each region. The second quick point is there obviously might be some non-science criteria that are going to be applied to what ultimately ends up being picked as a site. I mean, we haven't. In the work we did with my students, for example, we didn't consider that. But this is something that might come into play at some point, and so it'd be really interesting to stay abreast of what's going to compel us to favor, for example, a South Pole central site, like one of the ones that are really close to the South Pole versus one that is more peripheral. The other point also is that we might end up with a different site depending on whether we are viewing the Artemis 3 landing and its science mission as a one-off without any particular plan to return to that site in the long run, versus viewing Artemis 3 as the first of a repeat series of returns to the same site. Because that might actually take us to a different place, depending on how isolated we think of the Artemis 3 mission when it comes down to picking its site.
Yeah, so I want to emphasize that when we said down select, what we actually, a better way of thinking about it is prioritization. So as you heard Jack point out, the training burden is immense on the crew, and we want to try to preclude that. So we cannot carry, a large number of discrete sites. So that is a key component of our thinking. But I would encourage folks to think of it not so much as a down select as a prioritization as we iterate through the process and iterate through the architecture. And so, yes, as you point out, it will be an iterative process as we work our way through discrete sites and consultation with our contractual partners. So it won't be a down select, it will be a prioritization, and we're aware that of the complex interplay between when the flights happen and when they and the lighting conditions and the other various constraints we have to deal with as part of the integrated architectural. So that, yes, that is something we are certainly aware of.
Sam, this is Jack again. When do the operational people get involved in that site selection? When do you start getting the kind of issues raised like we had initially for Taurus Littrow, in that, well, the air ellipse is too big, it's going to intersect the slope of the North Massif, and then people got together and figured out how to deal with that. When do the ops people get in?
They're already pulled in, Jay.
Well, did we talk about that today or yesterday?
Yeah,
I mean, they're going to, and eventually they're going to make a lot of the decisions for you, I would hope.
We're aware of that. They're already part of the process.
Okay. I don't think that answers the question, Sam.
Well, they are pretty involved in the process already. So it's a different sort of is an interesting interplay between a lot of architectural elements, and that's why CASA was set up, was to try to integrate the various stakeholders across aspects of the architecture. So are you thinking in terms of EVA or in terms of lander, Jack?
I'm thinking in terms of all aspects of getting to the site and EVA. And my impression is that the EMU is being handled totally outside now of NASA. And I have no idea what kind of operational inputs are being made in its design. For example, the one that was recently subject of a press conference, the lighting was on the helmet. Well, that's probably the worst place you can have your lighting if you're going into a shadow. You want to see shadows, so you need to have your lights down lower so you see shadows. It's like walking your dog with a helmet light. You don't really get a good picture of the terrain. Now, whether that kind of thing is being discussed between the astronaut office and the ops people and the contractors, I don't know.
Yeah, well, those are all interesting points. I would encourage you to talk to Dr. Bleacher. Get a chance, and he'll.
Believe me, I have talked to a lot of people, and I still don't have a comfortable feeling that the operational aspects of working on the moon are really being taken into account yet.
And it's important to integrate the astronaut corps into that as well, obviously, Jack, as you well know.
Well, yeah, and I've been in touch with them, and they feel the same way I do. They don't know.
Those are all good points to bring up, but I did want to circle back to why we're here. Are there any other comments about the potential unique science value enabled by one of the 13 candidate regions?
Well, I would just say, I think that you're going to get exciting information wherever, at any one of those sites. That's true of the entire moon, as a matter of fact, as I think we've already demonstrated. It's the unexpected that is going to be the most important, I think.
I guess, Bill, just a question. You know, there are 13 sites that were or regions of interest that were announced. We didn't necessarily get to talk about every one in tremendous detail. The question, I guess, to the community, places like Nobile and others, you know, does anybody have any thoughts on areas that didn't get a specific session or anything like that? Strengths or reasons why some of your focus was on, you know, specific areas versus others?
Well, I'll just chase Jim Rice. I picked the Gurlash Rim 2 because I saw everybody gravitating toward the connecting ridge, which is a great site. I have nothing against, like I said, I don't have a favorite site at this point. I went around and looked at several sites in the process, and I just wanted to find one that hardly any literature or work had been done on, what I could find anyway. And I dug into it and picked it. That's why I picked that one. Nothing drove me there originally. You know, like Jack was saying, I think all these sites are great, and at this level, we're looking into it. But you know, at some point, when we start picking, you know, I guess I'm using the word region. I should be using that word instead of site. At some point, we pick a specific site or sites for a crew with that 2-kilometer footprint. You know, that's going to happen at some point, not too far down the road. But to me, at this stage, I didn't see anything to disqualify any of the sites or make them one rise ultimately way above the others. That illumination is going to be the key to me. That's the coin of this realm, and that varies with when you go. You know, and to me, this is such a different ball game than doing Mars landing site selection. It makes Mars landing site selection in some ways look pretty easy.
Yeah, could I add something about that too, Michael? Yeah, so you know, we did a preliminary survey of sites that might be suitable for an Artemis base camp, starting with Willett et al. In about 2 years ago, 2021, and Pimentel et al. Sophie's talk today was sort of a further study along those lines, and you know, we applied a set of criteria that had to do with having enough flat area to not just have a base camp, but to evolve it over time, be able to access high priority science target, both short range and long range. And so, you know, for what it's worth, we came up with 25 sites, locations, specific locations in the South Polar region. And as it turns out, all 13 of the Artemis 3 regions encompass these sites. So that's the good news. Some of the sites, so since you were asking about, do we have any comments about the sites that were not necessarily specifically addressed this time, some of these sites were rated low in terms of their prospects for an Artemis base camp down the road because they didn't seem to be very easy to expand from in terms of long range traversing, just slopes. For example, Malapert Massif was considered it's a classic site. It's I think for a short-term mission could be really fantastic as shown today, but it actually ended up ranking low in the base camp study because you're sort of trapped on that ridge. It's very hard to drive down it to get to other regions of the South Pole. So anyway, I just wanted to point out that some of these preliminary studies are out there, and they could be a basis for figuring out which regions we might want to focus on or not, depending on whether or not they offer long-term prospects for exploration and science access.
Yeah, those are excellent points. Any other comments on areas that weren't talked about, or because I have one overarching kind of just thought in my head is, kind of given some of the drivers for, let's call it the logistic challenge or the illumination challenge or scheduling challenge. What are the we've got the Artemis science definition traceability matrix. If we have the flexibility to be able to go to multiple sites or the need to go to multiple sites because of a schedule slip or something like that, are all of these, can they all address similar challenges or similar science tasks, or are some so similar that they can be in that kind of small pot of let's say schedule slip variability? That's a general question. I haven't looked enough at this. And I'll stop talking.
Hi, can you hear me?
Yeah, we got you.
Hi, my name is Jana, and I'm currently an intern at LPI, and I'm specifically looking at the 13 Artemis sites. Throughout my internship so far, one thing I realized is how terrain plays a huge role in you know in determining sites. And so when you mentioned Nubile Rim 1 and 2, it does have high scientific potential. One thing I found really cool about Nobile Rim 1 was there were a lot of hematite detections within the walls of the crater, which is really cool. But however, accessing the hematite or the really cool scientific findings like the M cube detections or any volatiles, it would be really, really hard to reach that. So I mean, so far, I think peak near Shackleton, although it hasn't been talked about too much, I do think that it would be reasonable to traverse around. And I do think Faustini has a lot of potential in terms of volatiles. And I do think that it is potentially traversable. So we did look into a bunch of different regions. However, we took traversability into a lot into account when determining the regions. So anyway, that was just what I had noticed so far. So thank you.
Yeah, no, that's great insight. And it is studies like Dr. Lee's group and the stuff that they're doing at LPI. These it's always a good exercise to go in and look at all of these and do these kind of regional surveys and things like that.
I think what you're hearing, I'll speak for myself, that I think other people are too. A lot of us are super interested in this process and keep continuing to work on it. And I know there's internal committees and going on, and that's all cool. But I think a lot of us really want to keep our fingers in the pie and contribute and help as much as possible. going forward. I know I do.
Oh, believe me, no, I am I'm well aware of the strong community interest in this process, 5x5. I mean, I got started working, for LRO in 2007. I took the job I took after graduate school in order to play a role in picking sites for Altair. So I do, believe me, Jim, I do fully understand the community interest in the process and just how important it is for everyone. So we're trying to strike a delicate balance of trying to, ensure that we fly a mission successfully, that it does as much as we possibly can do for all various stakeholders, while being as inclusive as possible in a relatively challenging environment. This is not Apollo. We have a lot of, we're operating now with these public-private partnerships, different modes of operations and different levels of allowable community input for various legal reasons. I think Jake has spoken in many instances about just how federal procurement sort of regulations and rules do actually impact a lot of what we do and have to interact with. So, but as a former AG chair, rest assured I am fully aware of how invested the community is in this process and how important it is to every one of you. Just that is a good message to carry to folks, is that we, especially those of us who work for agency, we work for you, and so we are trying to get the best possible outcome for all the various stakeholders. So it's not, we are always at all times cognizant of our responsibilities to all of you to try to deliver the best possible outcomes for this community. So it's not we're trying to work with you and are doing walking down the path of trying to do the right thing. Making sure we get as much science as we can out of these missions for the union.
Yeah, I don't mean it as criticism. I mean, thank y'all for doing all this. I'm just saying I want to stay involved.
Yeah, sure. Yeah. No, like I said, we do anticipate that that we do anticipate there will be future workshops on this topic moving over the next few years as we get closer to launch. I mean, let's see, nominal launch date 2025 is not that, late 2025 is not that far away. So we're continuing to work down that process. I will, oops, I'm being told it's a little far away from the microphone. So one of the other things I did actually want to bring up and make sure we made sure people were aware is that we do want to know from the community, especially from an LRO project perspective, what additional observations LRO can maybe do to facilitate these missions. We do have a strategic asset at the moon, so that's that is something important. So I'd encourage you all to, if you can think of new observations, to reach out to Dr. Petro and try to make sure we get those serviced while we have this amazing asset at the moon. With that, I think we're at the end of our time. I want to.
Sam,
Yep. Sorry.
I think
Sam, quick question still.
Oh, sure. I saw a hand back up. Okay, wasn't sure that was a new hand or an old hand.
Okay, well, since I have the hand up, quick question. My understanding is that there's going to be a uncrewed or unhuman HLS Starship landing before Artemis 3. Would that be going
It's an orbital mission.
side,
It's not
or would
landing.
it
It's an orbital mission.
disturb? No, that's Artemis 2. But there's a test flight of the human landing system
Sorry.
in the pipeline. That's what I'm talking about.
Japanese. I thought you were talking about the Japanese one. Sorry.
No, negative. Yep. No. So is that really in the planning, and would that be going to a site that would not be?
Yeah, that's a good question. There is a demonstration
the Artemis 3
mission.
site?
Yeah, there's a demonstration mission being planned. I believe Lisa Watson Morgan discussed that at the league meeting in August of last year. So it's being planned. We are presently that's a SpaceX mission, and so we are presently iterating with SpaceX aspects of that mission design. So I guess my answer to that question is stay tuned.
Mission design and landing site?
aspects of mission design would include land segment.
Understand, okay.
That's the one that's going to land, but not necessarily take off, correct?
Yep.